Welcome to have you.
Thank you. Hi, I am the Director of Data Engineering at HotelTonight, and I was hired at HotelTonight to fix their data warehouse because a year and a half ago, there was no one really managing the data warehouse, and it was kind of a nightmare. We had a lot of challenges and hiccups along the way with the data warehouse. So this is the story of how we overcame those challenges and how we found Snowflake and how it's worked out for us. So I'm going to talk about what HotelTonight is all about, why we need a data warehouse, what were some of the challenges with our existing one, how we assessed Snowflake and implemented it, and closing remarks. HotelTonight is an app, first and foremost. We're a mobile booking platform. We only exist on your phone. It's a beautiful app. It's really easy to use. You tap on the hotel you want. You kind of use your thumbprint to pay, and it works like in a minute. What's special about HotelTonight and makes it very different from other ways to get a hotel is that we are a last-minute channel for hotels to sell their unsold inventory. So they don't want 50 rooms to go unsold today. They'd rather sell them at a discount than nothing. And we're a place that they can put those rooms exclusively, and customers reap the rewards from that. And we have a very hand-curated set of hotels. So we only list hotels that we work with, and those hotels compete for your attention. So we only show you 15 hotels in any given list, and the ones we show you are the ones that give us the best value, the best deals. So it's basically a win-win for both hotels and customers. But to achieve this win-win and to be able to successfully offer the best deals to our customers and also the best platform for getting unsold inventory sold, we rely on data. Data drives the value at HotelTonight for both guests and hotels. Our data warehouse serves very time-sensitive and business-critical information to almost all the employees. Like maybe the dishwasher doesn't use Looker, but almost everyone else uses Looker at HotelTonight to get some data out of the system, even the engineers. So we report on things like how is our marketing doing, our advertising channels bringing in people who are likely to book, or are they just bringing in people who just want to browse? Are these people only booking once, or are they returning? Figuring out where we want to spend our advertising dollars is a really important business goal. Customer usage patterns, our product team is constantly wondering which features are people using, what are they paying attention to, what drives them to book. We have hotel managers who want to know which cities are people looking to book in, and do we have enough rooms in those cities? So a lot of times you'll find out, oh, this city is hot this week because of a conference we didn't know about, because the weather is great. Who knows what the reason is, but we now have to get on the phone to a bunch of our hotel partners and say, could you please load more rooms on HotelTonight? We need inventory. Or we might go and direct a campaign to add more hotels in that area. So all of these require data, and sometimes up-to-the-minute data is really important, because every time somebody comes to the app and doesn't find what they're looking for, we lose money. So our previous state, when I joined the company a year and a half ago, we had a legacy cloud data warehouse solution. We were bringing in all of our platform data. So this is the data that powers the app in real time. It shows you the current prices. It records your bookings. This is stored in MySQL, and we were ETLing it from MySQL into our data warehouse. We were also pulling in mobile app behavior. So basically our apps were sending us a stream of data telling us every action the person took, and we were trying to pull this all in. And all of our marketing spend was also very important to tie in and try to relate to our booking behavior. We have, like I said, 100+ analysts and managers using Looker to query this data. And we had about 2 million records coming in per hour, and about 10 billion total records. It's not the largest set of data out there because people don't book hotels as often as they send Snapchats, but This is still like a large variety of data that all needs to be joined together in very somewhat complex ways. So our cloud data warehouse was scalable, but I'm going to tell you why our scalable data warehouse really wasn't. The problem was compute is limited. In a scalable data warehouse, you scale it up to a certain size, and then there's a fixed amount of compute that you can use. And the problem with that is certain queries can be very expensive. You might be developing a new aggregation, and you want to join a bunch of stuff together, and suddenly that's using like half the compute resources of the system. And then your ETL slows down. So things that used to happen in sequence are now piling up and running in parallel. And then your analysts are not really understanding how databases work, so they see that their query hasn't returned, and then they issue that query again because they think, well, maybe it's going to come back this time. So you look and see what's running, and you have like 10 copies of the same thing running from the same analyst, and you've got 50 queries all trying to finish at the same time. And so my life was constantly being interrupted by, hey, Looker's down, you have to figure out how to get it back up. And so, of course, it wasn't Looker, it was the data warehouse, and I would be trying to figure out, is this query safe to kill? Is this person relying on this query going to be mad at me if I kill their query? There was a lot of manual intervention involved. Second problem is that even in a scalable data warehouse, storage is limited. Even if your actual data is not growing that fast, you can issue a very badly designed join and make the whole system run out of scratch space. So this was happening fairly frequently, that the data warehouse would essentially go down because one query used up all the scratch space, and then no one else's queries could finish. So this was a real headache, and all the people in the company who relied on data would be very frustrated and would come blame me for it. And I was like, don't blame me, this was here when I joined. So, so why didn't we just scale up? Because it's a scalable data warehouse. We did. We scaled up every 3 months. The reason we scaled up every 3 months and not more frequently was that it was a pain. So first of all, it would go into read-only mode for like 12 hours, and everyone would complain that their data wasn't available. And I would say I sent out an email telling you it wouldn't be available. And all the update queries that had been issued and all the ETL that had been happening would fail in the meantime. And then you would have to resume it, you have to backfill it. It was basically a major headache, and so I would try to avoid it. But the biggest reason I would try to avoid it is because once you go up, you can't go back down. The reason you can't go back down is because you experience that same headache all over again going back down, and then a week later you need to scale back up again, and you're like, why did I just scale back down? So the problem with not being able to scale back down is that you now have a permanent increase in your monthly cost. And so you have to justify an extra several $1,000s because somebody's query is running too slow. And so what you end up doing is you're like, well, maybe we can make that query more efficient. Maybe if we're running out of space, we can drop some non-essential data. We can prune this data. We can archive it. And then that data is not available to query. So you end up with this rule of thumb that before scaling, do everything possible to not have to. And this wastes a ton of time, because now your data engineers are spending all their time optimizing and pruning when they could be developing actual business value. So what's wrong here is that this kind of scaling is just too slow. What we wanted was faster scaling. And you can see that there's kind of been three stages of scaling. First, we had vertical versus horizontal. So vertical means you get a bigger box, and horizontal means you add boxes and figure out how to shard your data among them. That was kind of a decision that people used to have to make. And then the architecture came along where you can actually just add boxes and it'll redistribute the data for you, right? So this is the typical cloud data warehouse now, where you don't have to figure out how to shard your own data, which is a great advance. But it's this situation where once you add capacity, you can't go back down because the data is now spread across all of these nodes. The new school is what Snowflake is doing, which is you can scale up or down in response to demand within a minute. So if something is happening too slow, if some queries are getting queued up, I can just increase the size of that warehouse, and suddenly it's working again. And then I can scale it back down an hour later. It's kind of amazing. So Snowflake is not just enabling changing the size of a warehouse or adding additional warehouses, but it's also enabling this increased ability to scale storage, where you don't have to worry about these warehouses storing all of your temporary data. Everything spills into S3. So I've never had a query fail because there wasn't enough scratch space. I have taken so many queries that I had to break up into date ranges before and just run them without any date ranges in Snowflake, and they just finish. And it's amazing. It's like I can sleep at night. So that we had already been sold on Snowflake based on the scaling, but then we realized that there was this other issue that we were dealing with, which is all of our JSON data coming from our mobile apps. We were parsing this data as it came in, and then selectively picking out certain events and certain fields from those events that we knew analysts needed. And the problem with that is that our mobile engineers were constantly adding new events and constantly adding new fields to those events. It's like half of these fields were not there the last time I looked. Expensify, disable threat metrics, bug tracking early init flag. None of, like, if I had to change the ETL every time they added a new field, I would be spending all my time doing that. On top of that, the fields that we did add were all columns in our database, and it was like mostly null. So when you go and browse this data, it's really hard to like find anything or understand how it all works. Each event has its own properties, and all the rest are null, and it's just kind of a backwards way of storing things. So as you know, Snowflake can handle JSON. It allows you to query fields using essentially dot syntax. You actually use colons instead of dots, but otherwise it's the same as JSON. So you can dive into a nested structure and pull out the field that you want. And not only that, but you can actually just pull all the JSON in because you're not worrying about limited disk capacity. So now when somebody comes and asks, I want to analyze the referral program, and I want to go back and look at all the events of people referring people and see how much money we made, instead of saying, well, you can go to Mixpanel and get a count of referrals over time, but you won't know who was referred and you won't know how much money you made. We can actually now direct them to join this event data with all of our other data warehouse data and get like a actual answer to these problems rather than having these two separate sources that don't really talk to each other. This is, so those two major things were like both amazing to us. We went ahead and assessed Snowflake using a proof of concept. Over the course of a month, we wanted to make sure that our costs would be contained. So we had a planning tool that enabled us to decide how many warehouses we were going to have. We were going to separately allow the analysts to use Looker with one warehouse and then allow the developers to use a separate warehouse occasionally. And we'd have an ETL warehouse that wouldn't get interrupted by anyone else's queries. That's another major benefit of these virtual warehouses is that they're all independent of each other. So nothing you do on your developing warehouse will affect the analysts. And then we wanted to ensure that all our SQL would run. So everyone says that they run, that there's no changes, but there really are always SQL changes. So we wanted to know, how much of a development effort is this going to be? We ended up with like 10 regexes that translated a few non-standard SQL things, and it wasn't a big deal. We spent 2 months implementing, so we had to migrate all of our ETL over to Snowflake. We had to migrate all of our Looker reports over to Snowflake. We actually took the opportunity to purge a lot of our old Looker reports that no one was using or that were duplicates or something. So it took a little longer because we wanted to actually make a system that was even more usable. And we've been using it for 3 months so far. We're very happy with it. This is a chart that shows how happy we are. So in the yellow bars show when we added Snowflake to the system. So we were slowly migrating queries over to Snowflake. And so you can see that around July 25th, we started the migration, and then by September 5th, we finished it. And the red line shows what % of our queries were running in under 10 seconds from the analyst's point of view. These are analyst queries in Looker. The blue line is what % were under 30 seconds. The green line is under 2 minutes. We are now 95% of our queries are running in under 10 seconds and 99% in under 30 seconds. And that's very far from where we started, which was like 50% under 10 seconds and 75% under 30 seconds. So everything is much smoother. Analysts are much happier. I'm not hearing that Looker is down all the time. It's beautiful. So benefits, you can scale dynamically in real time. You can literally push a button and have more capacity, and then scale back down when you don't need it anymore. You can keep your analysts happy because they don't get interrupted by all of the other stuff going on. And you can free up your data engineers to do things that are driving business value instead of keeping the warehouse running. Current projects that we're doing at HotelTonight to drive business value, these are things that we've now been freed up to do because our data warehouse functions reliably. We're working on marketing optimization, so we are in real time determining which cities are performing well, where people are booking at a high rate, and we can afford to spend more on advertising for people who are searching for hotels in those cities. We are looking at predicting demand in certain cities so that we can tell the hotels in those cities how much they can expect to sell at various price points. So we can tell them if you want to sell out all 20 of your rooms, we can tell you what price to put your rooms at because we know how many people are coming. And then next year we'll be doing more around in-app personalization. This year we just launched a perks program that allows you to get even deeper discounts the more you spend at HotelTonight. And next year we'll be doing actual personalized results. And all of this is things that we wanted to work on, that I wanted to work on when I joined HotelTonight, and I wasn't able to until I got our data warehouse under control. TLDR, use Snowflake and use HotelTonight.